Hello, everyone. My presentation will include introduction, literature review, methodology, and conclusion. In simple word, what's building inspection? Building inspection is the process of assessing, evaluating, and documenting the physical condition, structural integrity, and compliance of building with relevant safety, quality, and regulatory standards. Why do we need to conduct a regular inspection? Conducting regular inspection helps us to identify any defects or weakness in the structure. Therefore, we can maintain safety and maintain safety of the public. Also, identifying any defects at early stages helps us to prevent costly maintenance. Regular inspection provide valuable data that helps asset managers to prioritize maintenance and take the right decision at the right time. Also, by identifying any potential risks in the buildings, owners and asset managers can implement measures and take the right actions. In the literature review, I'm going to take about the role of building information model and UAV-driven inspection, ground sampling distance, the challenge in the current UAV-based inspection methods. The role of BIM in UAV-driven inspection. We need building information model is an essential component when it comes to automating the process of building inspection. We need BIM to plan and to simulate the mission before we implement it in the site. The ground sampling distance and data collection is essential because, as you see, it's a function and the specification of the camera, as well as the distance between the camera and the surfaces we target to inspect. So from the equation of a ground sampling distance, we derive the required distance between the UAV and the targeted facades of the building based on a specific goal that we set before the operation of the inspection. The challenge in the current UAV-based inspection, there is technical limitation, basically in specifically in the path planning in the complex environment. Also, there is operational barriers, mainly in the life battery of the UAV, as most of the drones now has like life battery of between 40 and 50 minutes max. So if you have a big building, you have to conduct like more than 2 or 3 flights. And finally, the regulatory and ethical concerns. There is a lot of restrictions of flying a drone over 250 grams close to the airport and above the public. In this research, we developed a framework for automating the process of building inspection using UAV. Our framework consists of 3 main stages: planning, simulation, and execution stages. The first stage is the planning stage. In this stage, we determine the inspection goal, which is the cracks width or the rust intensity. Based on that, we determine that after we determine our goal of the inspection, we calculate the required distance between the drone and the targeted surface in the building. Then we calculate the field of view of the drone that we use based on the distance that we calculated earlier. And the second stage, which is the simulation stage, we start on the building information model of the building that we need to inspect. If the BIM model is not available, it can be created from the 2D drawings or by taking manual measurements. Basically, in the 3D model, we need a simple 3D model, just the measurement and the simple facades of the building. We don't need any like architecture details of the facades. After we simplify and have a clean BIM model, we grid the targeted facades of the building with the field of view that calculated from the planning stage. We generate, this grid can be done in many ways. In this case, in this proposed framework, it has been done automatically through Dynamo. So after we grid the facades of the building with the calculated field of view, we generate viewpoints at the center of each field of view. These viewpoints are at a distance D that we calculated at the planning stage. By creating these viewpoints, we create a grid faces each facade of the targeted building. So from this grid, we use the genetic algorithm to find the most efficient path that go through all the viewpoints to cover all the facades. And finally, the execution stage. In this stage, we extract the coordinates of the viewpoints from the 3D model and we convert it to the real-world coordinates, latitude, longitude, and altitude. And we execute the mission and we collect the data. In conclusion, this framework is proposed to make the process of the data acquisition for building inspection. And we leveraged GSD to calculate the required distance between the UEV and the targeted surfaces. And the framework is not yet experimented in real world at that time, but just last week I actually implemented in the site, and it's really effective. Yeah, thank you for your attention.